Hi, my name is Tammy Miller. In this nucleophilic addition video, we're going to learn to predict the product of an addition when oxygen is the nucleophile. When we're predicting the product of an addition when oxygen is the nucleophile, there are two different situations that we need to look at. The first one is water, and water is going to contain that oxygen that is going to be my nucleophile. When we have water, aldehydes and ketones will react to form what is called a geminal diol. A geminal diol, if we break the name down, Gemini are twins. All is an alcohol, that means there's a hydroxyl group, and diol means that there are two hydroxyl groups. So a geminal diol with two hydroxyl groups basically means that I have two alcohol molecules bound to the same carbon. Here, the oxygen from the water is going to act as a nucleophile and is going to attack that partially positive carbonyl carbon. Then, when we look at the reaction, this is actually a reversible reaction. We could remove the water, and that's going to convert the geminal diol back into the carbonyl. If we have an acid catalyst, this is going to increase the rate of the forward reaction, meaning that I will have more of the forward reaction, more geminal diols, than I will of the reverse reaction. So I'm going to end up with more of my geminal diols than my carbonyl carbons. When we're making a geminal diol, this is a type of hydration reaction. The second situation that we need to be thinking of when oxygen is the nucleophile is when we have oxygen in an alcohol that will be attacking. Now, when it attacks the aldehyde or ketone in a very similar manner to hydration, we're going to have that oxygen attack the carbonyl carbon. Here, we could get possibly two different products. If we have one equivalent of alcohol, if that one equivalent of alcohol is reacting to an aldehyde, what we're going to end up with is what is called a hemiketal. Hemi means half. So this is half of an acetal. And what that means is there is one OR group that came from the alcohol and one hydroxyl group. If the alcohol reacts with a ketone, we're going to get a hemi or half ketal. Again, there's only one OR group on here. On the other hand, if we have two equivalents of alcohol, the first equivalent will attack to make either the hemiacetal or the hemiketal. Then the second equivalent will attack again. And when that happens, if I have two equivalents attacking an aldehyde, I'm going to end up with an acetal. Here I have two OR groups. If I attack a ketone, I'm going to get a ketal. Again, here I have two OR groups that came from the alcohol. It's very important that we understand if we have one or two equivalents of alcohol. Let's take a look at a couple of questions where we want to predict the product in the presence of one equivalent of alcohol. First, the oxygen from our ketone is going to come down and grab the hydrogen on the alcohol, allowing it to release from the alcohol. When this happens, we will end up with a hydrogen on our carbonyl oxygen, making this oxygen positive. This makes the carbonyl carbon even more reactive. The next step that we're going to have is, because of the reactivity of that carbonyl carbon, our methoxy group now can come in and attack that carbonyl carbon, thereby giving us our hemiketal. And remember, it's a hemiketal because it only has one equivalent of an OR or oxy group on it. In our second example, we're going to predict the acetal formed in the presence of two equivalents of alcohol. Let's start with our first equivalent of alcohol. In our first equivalent of alcohol, just like with the hemiketal formation, the oxygen here on our aldehyde will come down and grab this hydrogen, allowing it to release from the alcohol. This, again, will then give me a hydrogen on my carbonyl oxygen that is now making the oxygen positively charged and is allowing that carbonyl carbon to be even more reactive. In the second step, the reactive carbonyl carbon will be able to be attacked by our methoxy group, thereby making us a hemiacetal. Again, one OR group, so it's hemi. This has two equivalents of alcohol. So we need to go to our second equivalent of alcohol. And I'm going to start with my hemiacetal. And I'm going to have my second equivalent here. In the second equivalent, my hydroxyl group is going to come down and it's going to grab onto the hydrogen on the alcohol, allowing it to release from the alcohol. This, again, is going to give me a positively charged oxygen. That positively charged oxygen does not want to be attached to three things. So what will happen is the water will ultimately leave. And that's going to happen in our next step. In our next step here, we're going to have our methoxy come in and attack that partially positively charged carbon, thereby allowing my water here to leave. At the end, we end up with a full acetal, meaning that I have 1, 2 OR groups that are attached. Understanding how to make hemiacetals and hemiketals in the presence of one equivalent of alcohol and an acetal and a ketal in the presence of two equivalents of alcohol is necessary for the understanding of the reactions of aldehydes and ketones.